So we're going to talk about one of the type of intramolecular bonds, which is covalent bond. Now, how do we know if it's actually covalent bond? It's when non-metal is combined with non-metal. For example, H2O. Are they both non-metals? Yeah. What about CO2? Yes, they are both non-metals. Even if we consider chlorine gas, right? We know that too when we put chlorine gas on its own. It's also non-metal. But this too means actually that we have chlorine combined with chlorine. They also have a bond, and this bond will be covalent bond. Now, what are the two types of covalent bonds? It could be polar and nonpolar. Now, why chemists decided to split covalent bond? That's because of physical properties of the compounds. But that's what we're going to talk about a bit later. Now, how to determine which compound is polar, which one is nonpolar? Polar compounds, and right now hear me out, I'm going to sound a bit fancy, but I'm going to explain everything I said. Polar compounds have bigger electron negativity difference. This triangle from math, it means difference. It's called delta. So I'm going to use that so that you know that I'm talking about difference. Nonpolar compounds have smaller electronegativity difference. What does it mean smaller? Smaller 100, smaller 0.1? What is it? Well, if electronegativity difference is smaller than 0.5, then it's nonpolar. If the electronegativity difference is bigger than 0.5, it's polar covalent bond. Very straightforward. Now, where to calculate those electronegativity? Is it going to be provided to you on the test? Are you going to talk about it before the test with the teacher? And where are those numbers coming from? Well, that's where we're going to go to our periodic table. Now, let's consider H2O. We have oxygen here, right? Here. We have oxygen here. And we have hydrogen over here. Now, we have lots of numbers on each square of the periodic table. You should know that the periodic table actually holds lots of information. You can learn and see from it lots of things. In this case, we can find electronegativity, actually the number, and it's right here. Electronegativity is usually from 0.1, 0.2, whatever those numbers are, the small numbers. Of course, it cannot be negative, right? And it cannot be 0. And it's up to 3 point something. Could be higher, of course, but we don't work with numbers like that. So we have 2.2 for hydrogen. Remember that. And we have 3.44 for oxygen. So let's write it out. We have, I'm going to put it somewhere over here. For H2O, we have for oxygen 3.44 minus 2.2. Okay. Oxygen, we put 3.44. This is our oxygen. And we put 2.20 for our hydrogen. Let's calculate this. And that gives us 1.24. If I calculated this correctly, let me know if not. So this is going to be the difference. Is it bigger than 0.5? Yes, it is. If it's bigger than 0.5, let's go back to this table. Is it polar? Yes, it is. So one of the examples of polar compound is hydrogen and oxygen. Now let's see nonpolar. Let's consider the example of CH4. For hydrogen, we already know it's going to be 2.20. Usually I put bigger number in front and smaller number on the second place just because I don't want to get negative numbers. Again, it doesn't matter, so we can get those. So it's 2.20. And C, we can look over here. It's 2.55. The number is right here. 2.55. Let me move the table. 2.55. All right, and the answer here will be 0.35. Is it bigger than 0.5? No, it's smaller. Therefore, according to the theory here, it's going to be nonpolar, CH4. That's the major rule, how to see which compound is polar, which one is nonpolar. Now, why is it important to know? It's important to know because it's very, very first reasons that we should know which compound can be dissolved in which solvents. What do I mean by that? Polar substances, right? I'm going to give another polar example, which is NH3. So, according to the rules, NH3 is polar compound. H2O is also polar compound. So, if H2O is a solvent, NH3 can be dissolved in that solvent. Dissolve. So, what's the point here? Polar compounds can only dissolve in polar solvents. That's how do we know that some compounds can be dissolved in water, because water is polar solvent. And we know that only polar compounds can be dissolved in polar solvents, such as water. Nonpolar compounds can be dissolved in nonpolar compounds. It's basically the rule is like dissolves like. That's it. Another example of nonpolar compound is HACl, Cl, Br, bromine, Br. Why are they like that? Because if you look at the electronegativity, let's consider chlorine, right? Chlorine, which I wrote right now, actually is Cl2. Let's look at the periodic table. Cl has 3.16. Now, calculate this. 3.16 minus 3.16, right? Because we have chlorine and chlorine. What is it? It's 0. Is 0 bigger than 0.5? No. So, it's smaller than 0.5. Therefore, what can we conclude? That ClCl is nonpolar. That's all.